Who's actually going to get the most out of a 1U chassis packed with 32 NVMe EDSFF drives, and who would be better off steering clear? Is the price tag justified for a business that just wants a little extra speed, or does it make sense only for heavy-duty workloads? If you're on the fence, you're probably wondering whether this kind of density will actually translate into real-world gains or just end up as unused horsepower. Link is in the description if you want to check the product details on Amazon. First off, let's talk about the problem this server is trying to solve. In modern data center environments, the bottleneck has shifted from raw compute to how fast you can feed data to those CPUs or GPUs. Think of a media production house that needs to ingest multiple 8K video streams simultaneously, or an AI research lab training models that read terabytes of training data every day. In those scenarios, every microsecond saved on disk I/O adds up, and that's where a high-density NVMe solution shines. The Supermicro SSG 136R NEL32JBF is built around that premise. It squeezes 32 EDSFF, the longer J form factor, NVMe drives into a single 1U rack unit. For a data center that's precious real estate, that kind of storage density can replace 3 or 4 separate 2U servers, freeing up space for additional compute nodes or networking gear. The chassis also includes the kind of server-grade power and cooling you expect from a brand that's been in the enterprise market for decades, meaning the drives stay within spec even under sustained heavy load. Now, who should actually consider buying this? The sweet spot is any organization that already runs a rack-mount environment and has a genuine need for ultra-low latency, high-throughput storage. Large-scale virtualization platforms, high-frequency trading firms, and research institutions with massive data sets will see immediate benefit. Even a mid-size media company that does real-time editing of multiple 4K streams can justify the investment because the ability to read and write across dozens of drives in parallel reduces render times dramatically. On the flip side, if you're a small business that only runs a handful of web services, or a hobbyist looking to build a personal NAS, this isn't the right fit. The cost per gigabyte is still considerably higher than a traditional SATA or even a 2.5-inch NVMe setup. Moreover, you need proper rack infrastructure, a dedicated power circuit, and enough cooling capacity to handle the heat that 32 drives generate. Without those, you'll end up spending extra on auxiliary equipment, eroding any perceived savings. Let's walk through a practical use case. Imagine a genomics lab that processes raw sequencing data in petabytescal batches. Their pipeline reads raw files, runs alignment algorithms, and writes intermediate results back to storage. By deploying the Supermicro JBOF, the lab can feed the compute nodes directly from the local NVMe pool, cutting the data transfer latency from several seconds to under a second per operation. The result is a faster turnaround on research projects and the ability to handle more samples per week without expanding the compute cluster. Contrast that with a typical small office IT setup where the primary need is file sharing and backup. Those workloads are more tolerant of a few milliseconds of latency, and the cost of 32 NVMe drives quickly outweighs the benefits. In that scenario, a simple 2U storage server with a mix of SATA and a handful of NVMe drives would be far more economical and easier to manage. One practical strength of the SSG 136R is its built-in remote management. Supermicro's IPMI interface lets you monitor drive health, temperature, and power consumption without having to be on site. That's a big win for administrators who need to keep an eye on a dense storage array 24/7. The drive bays are hot swap capable, so replacing a failed drive doesn't require a full system shutdown, a crucial feature when you can't afford downtime. However, there are a few trade-offs you should be aware of before you click Add to Cart. The sheer number of drives means a higher overall power draw, typically in the range of several hundred watts just for the storage subsystem. If your data center's power budget is tight, you'll need to factor that into your calculations. Heat is another hidden cost. 32 NVMe drives produce more thermal output than a comparable SATA array, so you'll need sufficient airflow and possibly additional fans to keep temperatures within the optimal range. Another point that often catches buyers off guard is the compatibility of the drives themselves. The EDSFF J form factor isn't as widely adopted as the standard M.2 or U.2 modules, so you'll need to source the right NVMe models. That can limit your ability to mix and match drives from different vendors, potentially affecting your ability to upgrade or replace drives cost-effectively in the future. From a value perspective, the price makes sense if you compare it to assembling the same capacity with multiple separate servers. You end up paying for the density, the integrated management, and the reduced cabling complexity. For an organization that can actually use the full 32 drive bandwidth, the return on investment shows up in faster data processing, lower latency for critical applications, and